All right. All right. Pod 5, what was your function?
Okay. X squared plus 4x.
And what was your derivative?
2x.
Did they ruin the day already?
What?
They ruined the day. They ruined the best day.
Ruined it. It's the best.
This is the best day so far.
We're going to come back to that.
So smart. You done best.
Okay, right here, what was your function?
2x cubed.
And what was your derivative?
6x squared.
Okay, right here, pod 6.
We had 4x squared.
And your derivative?
8x.
Oops. Okay. Who else do I don't have yours.
X
X2.
or sorry, x cubed.
Derivative?
3x squared.
All right.
Oh my gosh.
Heidi and Dylan, did we fix it?
On my way.
Okay.
Squared, you multiply by 4. I found the power rule.
All right, over here.
Square root x.
Derivative.
She's been holding
1
secret
over
back the
well,
whole
I'm
time.
living at 10:08 a.m. and he's at like 10:30.
2x plus 3.
So we can do it for no reason.
I'm gonna say for no reason. Okay. Brayden thinks he has it figured out.
Well, for like if it's a cube, you multiply the coefficient by 3 and then take away an exponent. So it'd be like 6x squared.
So for each of these cubic ones, we took the 3 and multiplied it by the coefficient, and then the exponent became a 2.
Yeah.
Okay? What else?
Same thing with the squares.
Same thing with the squares. The square gets multiplied and, okay. So he has noticed in 2 family of functions, we can take the exponent, multiply it to the coefficient, and then what happens to the exponent?
It goes down.
It goes down by 1. Oh, okay. What about that one?
Same.
Man, I didn't trick you at all. This is x to the 1/2 power. Okay, so describe your rule to me. Okay, we take the power and we multiply it by the coefficient, and then we do what? Drop the power by 1. Man, you guys are good. Guess what? Except for one time on the quiz and the test, you don't have to do the limit definition anymore. Because, come on, people, is it efficient?
No.
No, it's not efficient. It drives us all nuts, right? Okay? It's very tedious, okay? Well, mathematicians, they work really hard to look for patterns, and if these patterns can be established as something that always happens, then we can use it as a rule. So, ladies and gentlemen, welcome to the power rule. And you all just figured it out, okay? The power rule, if we have a function, ax to the n, okay, this is generalizing it, then when we take the derivative, we take our exponent and multiply it by the coefficient and decrease our power by 1. Exactly what Brayden was describing is what's happening every time. Write it down. This is going to save you so much time. And now I can give you more problems to do because they'll take less time.
That's why it's written the
I'm
best
just
day
kidding.
ever.
I really don't give you that many more problems.
You get questions of white all
Okay? Now, it's not all the time where you are literally going to get a x to the n power. So if it does not look like a x to the n power, you cannot use the power rule until it looks like a x to the n power. And I'll show you what I mean, okay? Make sure you rewrite it so that it is in that form before you take the derivative. For example, maybe you have x squared times x to the fourth. Well, write it as x to the sixth before you take the derivative, okay? Things like that. And we'll go through lots of different examples of what we need to do, okay? Are you ready? Brittany's all ready. You sure? Okay. I'm sure you are. All right. So, it's going to take you longer to write this down than it is for you to think about the answer, in my opinion. Okay? If f of x equals 2x cubed, and I'm going to be kind of obnoxious right now, I'm going to write it out as, just so you can all visually see what's happening. We take our coefficient, we multiply it times the exponent comes down, and then our exponent decreases by 1. So we have 6x squared. Write this one down. Bless you. And ask yourself, does this look like ax to the n? I don't see a power. I can't use a power rule on something that doesn't have a power. But can we rewrite it to have a power?
Yes.
Okay, so we need to rewrite this to be f of x equals 1/3 x to the 1/3 power. And now we can take the derivative. Okay, so now we can take our derivative to be 1/9 x to the what power? Very good, -2/3. We subtract our power by 1. So 1/3 minus 1 would be the -2/3. And you don't have to rewrite it. Okay? You can just leave it like this. I'm fine with negative exponents. Okay? We don't have to rationalize or do anything like that. Just leave it. Okay? All right. Y equals 6 over the 5th root of x cubed. Is this written as ax to the n?
No.
No. Write down what you think we should rewrite it as.
Multiply 3 times 1/5 because that's like,
Okay.
I just don't want to.
Okay, Kinley, what would you rewrite this as?
6 times x to the, is it negative 3?
Is it negative 3/5, she asks. Okay, we have 3/5 would be in the denominator, and so when we move it up, it does turn negative. That's correct. Okay, please do not leave your x to the power in the denominator. That's not how the power rule is written. It's not going to work. We have to move it up to where we have a x to the power, okay? So this is technically x to the 3/5. We move it upstairs, it becomes negative. So our derivative would be negative 18/5 x to the, what power? Negative 8/5. You gotta subtract 1. So subtract 5/5. Alright, what do you think? This is so nice. Like, it takes us seconds instead of minutes to do these. Okay. Alright, now, you kind of saw this when we, I think I had, like in Pod 5's example. Okay. Like in Pod 5's example, we basically use the power rule twice, essentially. Okay, that's okay to do. And don't think you would need to write this down. Okay, let's just look at it. If we are adding or subtracting functions, we can take the derivative of the first and add it or subtract it to the derivative of the second and keep going that way. We can just chunk them out in between addition or subtraction. Okay? Same thing if you have something multiplied to your function, you can keep it inside with and take the derivative, or you can take the derivative and then multiply by the constant. It doesn't really matter. That's really not something that you are going to think about a lot until we get later into our unit, but just know that that's okay. All right? Okay, to go along with our power rule, I'm going to give you 2 other rules that you have to know. If you do not know these, you're going to struggle. If you don't have these in your head, you're not going to be able to do the next unit and then the next unit and the next unit. Like, there's no other way to say it than you have to memorize these, okay? Luckily, they're very much related. But the derivative of sine is cosine. You have to know it. The derivative of sine is cosine. What do you think the derivative of cosine is? So close. Negative sine. The derivative of cosine is negative sine. Did I teach you something new today? Oh, you knew that today. Okay.
It's for life.
How'd you start reading?
But like, why was she in pre-class to begin with?
Oh, they said normally put them in there.
Yeah.
Because the other semester they have algebra too. And one also changed.
Yeah.
She also said she's just
And you're complaining? She's sitting next to you. She's bringing you all up.
yeah. And then she gets her grades back and like breaks it down.
Okay, so I was gonna like prove to you why these are true, but I'm gonna go ahead and skip it. Is that okay?
Yes.
Here. What did you say?
Yes, thank you.
Okay, so I want to do this derivative. Write down what you think the answer is. Okay, so. Okay.
You're gonna understand. X is 0 1. Anything is 0 power to 1.
Wow.
All right, what's the derivative of x? 1, okay? The derivative of x is always just going to be its coefficient because x to the 0 is 1. Okay, so when we do the power rule, the x is going to disappear and we'll just be left with the coefficient. Okay? And then what do we have after 1? Miss Courtney?
Negative sign.
All right, so we have 1 minus sine of x. Done. Woohoo! Okay?
If it's cosine x, if it's cosine squared x, would it just be negative sine squared?
It is not. It is not. Once it gets to cosine squared, then we have a different rule. Okay, so Unit 2 is all about how to take derivatives, and we're starting really, really simple with the power rule. Next week, we're going to talk about something about the product rule and the quotient rule. So if two functions are multiplied together, how do we take the derivative? If two functions are being divided, how do we take the derivative? Okay, so as we go through the weeks, like over the next 5 weeks, you're going to, not worse, you're going to have more tools in your tool belt. You're very limited right now on what you can do. You can only do the power rule, sine and cosine. So as we, each day we're going to add more tools.
Tool is more difficult to use than the last. So,
Catch me driving this class next week.
Oh my goodness. Okay? I have a question. Do you enjoy having a variety of options in order to do a problem?
Yeah.
That is what Unit 2 is about. Okay? What are the different ways we can take derivatives? Okay, write this down.
Got it.
And we might have 3 different ways we can do a problem, but which way is going to be more efficient? Okay? Which one's going to help us more in the long run? Okay, so this totally does not look like ax to the n. Does it?
No.
No. No, it doesn't. What?
Subtraction thing, so you just find the power, you just use the power rule to isolate the other ones.
Okay, we're going to have to write this as 4 different power rules. So we are going to have to do this division. We're going to have to split this up. Okay? So 2x cubed divided by 2 squared of x. Well, this is the same thing as x to the 1/2 power. Right? So 2 divided by 2 cancels out, and we're left with x to the what? X cubed divided by x to the 1/2.
Flip the second guy multiply to the 6.
X to 6.
3 s. Negative 3 s. 3 s.
Oh, because you gotta subtract 4.
Oh, so if you divide.
I still don't know if I like 3/2 though.
What would be 6?
What's the question?
Oh,
It's 5.
isn't it 5/2?
Oh, it's just gonna go with 5.
I
Right?
don't know the question.
Wait, no, because we're doing 3. Okay.
Okay.
When you're
We're doing 2x cubed divided by 2x to the 1/2.
Yeah.
Minus 3x squared divided by 2x to the 1/2. Plus 7x divided by 2x to the 1/2. And 5 over 2x to the 1/2. So we need to write each of these individually as ax to the n. So when we are dividing and we have exponents, what do we do with our exponents?
Subtract.
We subtract. And what is 3 minus 1/2?
2.
Okay, so we have x to the 5/2 minus 3/2 x to the plus 7/2 x to the This is 1. This is 1/2. So we're still at positive 1/2. But over here, we would have 5/2 x to the negative 1. Looks terrible. Now we can do the power rule with 4 individual terms.
Oh, so that's what it's confusing. So we're just getting it to equal that so we can do the subtract 1 later with it?
Yes. So we had to break this up into 4 individual terms so that now we can actually perform the derivation. So
You lost me there for a second. I'm back. I'm back.
Yeah, I was thinking, like, my brain is, like, dying.
I'm sorry. I'm sorry. I'm sorry.
I love to.
So our derivatives. So okay. Are we all okay with what we have in blue
Sure.
and how we got there?
Yes.
Trenton, ask me a question.
I guess I'm just confused on how you got that.
Okay, so are you cool with like we're performing the division of over 2x? Okay, so anytime we are dividing and we have exponents, we subtract our exponents. So x cubed over x to the 1/2, 3 minus 1/2 is 5/2.
Alright.
Got it?
Yeah.
Thank you for asking your question. Any other questions about the blue? So now our derivative, power rule. 5/2 times x to the, we subtract 1, 3/2. Okay. Minus, we have a coefficient that's going to get multiplied by our power to make 9/4 x to the 1/2. Plus, we have a coefficient of 7/2. It's getting multiplied to our power. So we get 7/4 x to the negative 1/2, because we subtract 1. And then we have 5/2 as our coefficient. It's getting multiplied by our power, so negative 5/4 x to the, we subtract 1 for negative 3/2. I can't tell what kind of tone that is, but I'm going to accept it. Okay. Yes. Yep. This is what you're going to leave it as. Isn't that nice? One more problem, and then I'm going to let you work on your homework for 10 minutes. You don't get that. You don't get that very often. Okay.
Is this why this is the best day so far? Because I get 10 minutes to work on them.
It's one of the. It's one of the ways.
Oh, what the heck?
Last question. How is she?
Okay, so you said we had like 10 minutes and
Yeah.
separate. I don't know if I can do it all in 10 minutes. And she's like, well, you can work on the one that you didn't do.
She's holding you accountable, Trenton.
She is.
Holding you accountable. Okay, can we take the derivative right now?
No.
No, next week we could, right now we can't. Okay? Today our only option is to do what with this?
Gotta multiply it out.
Gotta multiply it out. Okay? So first, we have x times 3x plus 2, 3x plus 2. Okay? We gotta actually perform that multiplication so we can use the power rule. So, 3x plus 2, the quantity squared, would be 9x squared plus 12x plus 4. Then we have to multiply the x through to be 9x cubed plus 12x squared plus 4x. Okay? Some of you might feel annoyed by all that work. Okay? Well, next week I'll teach you a different strategy you can use. Okay? But now, are we to the point where we can take a derivative?
Yes.
Yes. Now, we can say dy dx is 27x squared plus 24x plus 4. Okay. And what I'm going to do for you both today and on Monday, I'm going to post my worked out solutions to these problems. I don't always love the way that the book simplifies their answers. So I'm going to ask that you go to my website and check your answers based on how I expect you to do the problem, because the book is going to take it and simplify the answer more than I think is necessary, and I don't want you to get caught up in that algebra. I want you to focus on the calculus. Does that make sense? Okay, so you have 9 minutes where I want you to start your homework.
We'll take a minute late this year.
Yeah, the Apple time does not correspond to
To go.
when the bell rings.
It's about 20%.
Because
We can time it today.
what?
We'll time it today. We'll figure out exactly.
Okay.
Let me know for sure.